The black hole hypothesis has proven remarkably adaptable. I would hesitate to call it a theory, since a true scientific theory demands not only observational evidence, but also predictive power. In science, the terms testable and falsifiable are synonymous, and whether black holes meet either standard is debatable. Observations of alleged black holes, or at least the matter swirling around them, often contradict the original concept, yet the idea has proven flexible enough to absorb these contradictions, much like a vaguely worded horoscope. If it's your birthday today, you might get some presents. With black holes, though, every day seems to be their birthday. Billions have been spent studying and speculating about these enigmatic objects. To astronomers, black holes are much like dinosaurs are to children: big, exotic, mysterious, and endlessly stimulating for the imagination. The story is further complicated by the fact that the black hole concept began as a placeholder. Observers noted compact energetic activity at the center of galaxies, raising questions about what was happening there. In a gravity-dominated universe, a mathematical abstraction was invented to explain the phenomenon: points with zero volume, infinite density, and infinite gravity. Somehow, though, this speculation solidified into dogma, and to question the tenuous hypothesis is now seen as scientific heresy. Consensus scientists who describe black holes as one of the most successful predictions of relativity generally choose to ignore the fact that Einstein dismissed the idea. In a 1939 paper from the Annals of Mathematics, he concluded that the black hole hypothesis was, quote, not convincing, and the phenomenon did not exist in, quote, the real world. The paper is now hidden behind a paywall, but it is referenced, for example, at history.com. Unfortunately, it seems pop science didn't get the memo. A recent MSN article on black holes and quantum gravity, grandly titled, quote, "This is the holy grail of theoretical physics," declares, quote, "black holes are relevant to this because they first theoretically emerged from the solutions to the Einstein field equations that underpin general relativity." Mainstream puff pieces of this kind are all too common. As Einstein himself once warned, quote, "As far as the laws of mathematics refer to reality, they are not certain, and as far as they are certain, they do not refer to reality," end quote. To be fair, establishment science finds itself in a bind. Galaxies spin too fast to be held together by their visible stars, planets, and gas. The remedy? Invent missing mass by the trillion, christen it dark matter, and then enthrone at each galactic core a black hole of unimaginable proportions. Both props rest on the same conjuring trick, claiming mass where none is seen. And at the heart of it all lies the singularity, a mathematical ghost demanding zero volume, infinite density, and infinite gravity. A state of affairs no law of physics will tolerate. Thus, the story of galaxies becomes a parable of modern cosmology itself. Contradictions piled on contradictions, abstractions masquerading as reality, and the impossible declared indispensable. It's science by decree, not by demonstration. The mathematician Stephen Crothers is regarded as a leading critic of black holes and relativity. Hailing from Tasmania, Crothers is not one to pull his punches. Quote, "This is how astronomers and cosmologists do science, fraud by means of mass media-induced mass hysteria. It beggars belief. Think about it. According to the astronomers and cosmologists, the finite mass of their black hole is concentrated in a physical singularity of zero volume, infinite density, and infinite gravity. But no finite mass has zero volume, infinite density, and infinite gravity." End quote. His work, though often ignored, strikes at the root of the problem: a physics that privileges elegant geometry over physical reality. The result is an academic inertia so dense that even light or insight can barely escape it. From the start, black holes were supposed to be the ultimate cosmic sinkholes, invisible objects from which nothing, not even light, could escape. Yet the very features astronomers now celebrate as black hole signatures flatly contradict that premise. Take the colossal jets of plasma blasting out at near light speeds, oriented perpendicular to the plane of rotation and often extending for thousands of light years. If nothing can escape the event horizon, what business do these jets of plasma have punching through intergalactic space? Meanwhile, cosmology seems trapped by its own creation. Like dark matter before them, black holes have become mathematical conveniences, invoked wherever gravity alone falls short. Are they discoveries or declarations? Placeholders for what the theory cannot explain, and symbols of a science that would rather invent unseen entities than confront its own contradictions. To save the hypothesis and account for these mysterious jets, astrophysicists introduced the ad hoc notion of an accretion disk, a turbulent ring of infalling matter conveniently invoked to power them. But this was never part of the original prediction. It was a patch, pure and simple. Accretion disks supposedly work something like huge jet engines, blowing out material before it reaches the black hole, despite their previously inescapable power. One might call it a cosmic improvisation. When nature misbehaves, theorists add more knobs, levers, and belts until the model fits the spectacle. According to Einstein's relativity, the speed of light is the ultimate unbreakable limit of the universe. Nothing can surpass it. Yet, black hole theory insists that, at the event horizon, the escape velocity does exactly that. It exceeds light speed. This is not simply a subtle puzzle of advanced mathematics, it is a flat contradiction of the very principle on which relativity rests. In short, black holes violate Einstein before they even begin. Their paradox is conjured from the equations, not phenomena confirmed in the heavens. Likewise, if black holes are meant to be invisible, why is it that we can see them at all? The famous image of M87's black hole was not a direct photograph of an event horizon, but a composite reconstruction of glowing plasma surrounding the region. The light we detect comes not from the black hole itself, but from the very matter it was never supposed to allow us to observe. We must turn again to plasma in the closing chapter. Critics have challenged the M87 image's interpretation, pointing out the heavy reliance on computer models and the degree of data filling in. In truth, what was presented as a window into the abyss was as much an act of imagination as observation. From universemagazine.com, quote, Makoto Miyoshi, a researcher at the National Astronomical Observatory of Japan, and his colleagues say that the high-energy jet is missing from the EHT photo. Moreover, in their new photo of the black hole M87, in a panoramic view, there is no ring of light in the form of a donut, which means that the photo of 2019 turned out to be false. End quote. Even within theoretical physics, consensus is elusive. Stephen Hawking once suggested that black holes might not destroy information, only to later contradict his earlier position, igniting a long-running debate with Leonard Susskind and others over the so-called information paradox. If the brightest minds in the field cannot agree on whether the fundamental laws of physics survive contact with a black hole, one has to wonder how stable the idea really is. The famous debate was handed down for posterity by Susskind in his book The Black Hole War. It ended shortly before Hawking's death in January 2014, with Hawking's admission that there is no event horizon and therefore no black hole in the sense of the theory. Hawking even recommended redefining black holes as a five-dimensional space, whatever that might mean. More math, less meaning, some might say. When matter spirals into a black hole, it heats up and blasts out radiation across the spectrum, from optical light to X-rays. At a certain point, that radiation should push back on the infalling matter and halt further feeding. This ceiling is known as the Eddington limit, nature's supposed speed limit for black hole growth. Yet, NASA's Chandra Observatory recently found a quasar apparently smashing straight through it. This black hole, a billion suns in mass and shining only 920 million years after the Big Bang, is gorging itself faster than the rule book allows. Lead researcher Luca Ichina admitted, quote, "It was a bit of a shock to see this black hole growing by leaps and bounds," end quote. Once again, black holes behave less like obedient mathematical abstractions and more like rebellious rock stars, refusing to play by their own supposed limits. I'm reminded of Nigel Tufnell in This Is Spinal Tap, proudly pointing at his amplifier and explaining why it's louder than everyone else's. Quote, "This one goes to 11. It seems that being a black hole is a competitive business, where the motto is the bigger the better. Each new discovery seems determined to outdo the last. Let's not forget the very concept was speculative to begin with, and that was before supermassive black holes took centre stage. Then came the ultramassive variety. How long before we are introduced to the super duper humongous mega deluxe black hole? The media certainly plays along. A recent Daily Mail piece announced reassuringly, quote, "If the thought of a supermassive black hole terrifies you, a new study may provide some relief." According to researchers at the University of Southampton, UK, a void some 12 billion light years away turned out to be 10 times smaller than expected. The article added with admirable understatement, quote, "It could lead to a re-evaluation of our models of cosmic evolution." Translation: for years we may have been over-egging the pudding, or, to borrow a more cosmic metaphor, inflating the flan. The black hole story grows bigger, then smaller, then bigger again, depending on the data. In the end, the only thing expanding reliably is the elasticity of the hypothesis itself. An article in Universe Today reported, quote, "Too big, too soon. Monster black hole seen shortly after the Big Bang. This black hole grew far larger than we expected in only 690 million years after the Big Bang, which challenges our theories about how black holes form." End quote. Yet again, size seems to be a moving target. Is a monster black hole bigger or smaller than an ultramassive black hole? Perhaps the naming convention will soon require its own taxonomy. Just when you thought cosmic weirdness had peaked, along comes the black hole star. Yes, really. The James Webb Space Telescope, JWST, has apparently uncovered yet another new class of object, a black hole pretending to be a star. You couldn't make this stuff up. Mainstream astrophysics has long held that when a massive star exhausts its nuclear fuel, gravity wins the tug of war, crushing the core into a singularity. Voila, a black hole. But now some of these collapses are too hungry to remain invisible. Feed them enough gas and they start to glow like stars themselves. It seems some black holes now moonlight as stars. The invisible monsters now insist on being seen in defiance of gravitational decorum. If that's not proof that the universe has a sense of irony, I don't know what is. And of course, like Spinal Tap's amplifiers, these cosmic stars also insist the dial goes to 11. Phys.org reports that black hole luminosity should evolve at glacial pace over thousands or even millions of years. Yet MIT's Erin Kara observed, quote, "We saw it change by 10,000 over a year, and even by a factor of 100 in 8 hours, which is just totally unheard of and really mind-boggling." End quote. From a plasma physics perspective, such behavior is not strange at all. The corona of these objects act like plasma circuits. When the current fluctuates, the glow responds. Nature, it seems, comes with its own dimmer switch, attuned to electricity, not gravity. Modern cosmology, however, continues to play high priest to an older faith. Its dogmas are mathematical, its rituals computational, and its miracles written in equations. What was once religion by revelation has become religion by simulation, a creed of unseen forces defended with the same zeal it once condemned. Just when you thought black holes couldn't get any more versatile, along comes a new theory. Maybe the entire universe is inside one. Yes, that's right. According to a group of researchers led by Enrique Gastonaga at the University of Portsmouth, UK, the Big Bang might not have been a Big Bang at all, but a big bounce. The rebound of matter collapsing into a black hole in some other unseen parent universe. In other words, we're not just circling a cosmic drain, we're living inside it. It's the astrophysical equivalent of a Russian doll, a black hole inside a universe inside another black hole. Of course, the irony is delicious. For decades, cosmologists told us black holes were inescapable death traps where time and matter go to die. Now, apparently, they're also cosmic wombs giving birth to whole new universes. Black holes are no longer just stellar corpses or intergalactic vacuum cleaners, they're also midwives. At this point, you start to wonder whether black holes have become a kind of narrative duct tape. Stick them anywhere you need to patch a hole in the story of the cosmos. Star too big, black hole. Star too heavy, supermassive black hole. Don't know how the universe began? Must be a black hole in another universe. I would suggest that if they really think we are living inside a black hole, then the only thing collapsing faster than space-time is the reputation of theoretical physics. The Electric Universe EU model, championed by the Thunderbolts project, offers a more simple and more predictive explanation for galactic centers than the gravity-only model. Space is teeming with plasma and electromagnetism. Plasmas, ionized gases with freely moving electric charges, emit light when energized, form spectacular jets when guided by electric currents, and can sustain structures over vastly different scales. The universe, it turns out, is wired. This vast electrical circuitry has only become visible with the advent of modern radio astronomy, tools unavailable when gravity-only models first solidified into dogma. Quote, in order to understand the phenomena in a certain plasma region, it is necessary to map not only the magnetic but also the electric field and the electric currents. Space is filled with a network of currents which transfer energy and momentum over large or very large distances, end quote, Hannes Alfven. The energetic phenomena observed at the centers of galaxies, jets, corona, and quasars resemble plasmoids, self-organized structures of plasma stabilized by magnetic fields. These plasmoids scale across many orders of magnitude, from small laboratory discharges to galaxy-spanning structures, making them far more adaptable than a gravitational singularity that can only exist at one scale. Their predictability comes from well understood electromagnetic laws, not mathematical abstractions that defy observation. Quote, the underlying assumptions of cosmologists today are developed with the most sophisticated mathematical methods, and it is only the plasma itself which does not understand how beautiful the theories are and absolutely refuses to obey them. End quote, Hannes Alfven. In this view, so-called black holes are not mysterious, invisible voids, but the visible endpoint of vast cosmic electric circuits. The accretion disks, glowing corona, and relativistic jets are natural consequences of electromagnetic interactions, not ad hoc fixes. Redshifted companion galaxies, quasars, and sudden luminosity changes fit naturally within this framework. Plasma responds dynamically to variations in the circuit, producing brightness fluctuations that are observed over hours, years, or even millions of years. Quote, my experimental work in plasma physics for the last 36 years has shown that under many different circumstances, plasmas containing non-relativistic or relativistic electrons can spontaneously organize themselves into force-free, minimum-free energy vortex filaments of a Beltrami morphology, end quote, Winston Bostick. In short, plasmoids provide a physically grounded, scalable, and observable explanation for phenomena attributed to black holes. They transform the placeholder hypothesis into a testable model, illuminating the universe with real structures rather than imaginary singularities. The universe, electrified and observable, is far more elegant than the gravity-only abstractions it replaces, and, unlike black holes, it doesn't need a team of theorists patching it up every time it misbehaves.